First example involving equations with fractions, 2 over 3x plus 4 equals 11. What we want to do is to get rid of this dividing 3, and the only way that we can do that, or the best way that we can do that, is to multiply by 3. Now I'm not going to multiply everything by 3, I'm going to multiply this 2 by 3, this 4 by 3, and the 11 by 3. So what do I get? 3 times 2 is 6. You'll notice that the 3 on the bottom is still there, and the x is still an x. Plus 4 times 3 is plus 12, and 11 times 3 is 33. 6 divided by 3 is 2, so we have 2x, and the fraction has disappeared. 2x plus 12 equals 33. You can solve this equation by subtracting 12 from both sides. 33 take away 12 is 21, and we have 2x on the left hand side. Divide by 2, x equals 21 over 2. We don't need to reach for a calculator or write that as a decimal, we can leave it as a fraction. This second example is just a little bit more complicated. You see that we have two fractions, 1/4 and 2/5. Now the best way to get rid of a dividing 4 and a dividing 5 is to multiply by 20. 20 is the smallest number that can divide by 4 and by 5. Now what am I going to multiply by 20? I'm going to multiply the 1, the 5 and the 2. So 20 times 1 is 20 over 4 x. 20 times 5 is 100. 20 times 2 is 40 over 5. Now, let's look at the first fraction. 20 divided by 4 is 5, x minus 100. 40 divided by 5 is 8. No fractions, so we should know how to proceed. We'll add 100 to both sides to get the 5x term on its own. 8 plus 100 is 108. That leaves us with 5x on the left hand side. We'll divide by 5 and x equals 108 over 5. This third example is different again. What we should do here, I think, is I'm going to take the dividing 6 out, and I'm going to write it as a sixth. And I'm going to put the x plus 4 in a bracket. So I'm just changing the appearance of the equation. That makes it clear, I think, at least I hope it makes it clear what we're going to do. We've got a dividing 6 that we want to get rid of, so I'm going to multiply by 6. Now, what am I going to multiply by 6? I'm going to multiply this 1 by 6 and the 2 by 6. I'm not going to multiply any of the bracket by 6. There's a reason for that. 6 times 1 is 6 over 6. The bracket remains unchanged. 6 times 2 is 12. 6 divided by 6 is 1. Expand the bracket. 1 times x plus 4 is simply x plus 4. Subtract 4 from both sides, and we have x equals 8. Fourth and final example. We've got a dividing 4 and a dividing 6. Now what I'm going to do first is to change the appearance of the equation. I'm going to bring that dividing 4 out and write it as a quarter. I'll put a bracket around the 3x minus 1. I'll take that 6 out, write it as a fraction 1/6, and then bracket around the 2x minus 5 equals 1. So there we have it, just change the appearance. The smallest number which divides by 4 and by 6 is 12. Some of you may multiply the 4 and the 6 to get 24 and use that, that's okay, but the smallest number is 12. I'm going to multiply the 1 by 12, this 1 by 12, and this 1 by 12. So 12 over 4, 3x minus 1, minus 12 over 6, 2x minus 5, equals 12. 12 divided by 4 is 3. 12 divided by 6 is 2. We can now expand the brackets. We don't have any fractions to worry about. 3 times 3x is 9x, so that's 9x, take away 3. Minus 4x, be careful, we have minus 2 times minus 5, which is a plus 10. Now, some of you are getting into the bad habit of doing things like this. That is wrong, it's very wrong. We only do that if we're working on different sides of the equals sign. So, let me just rub those out. What we should be doing here, of course, is simplifying, gathering together like terms. So I'm going to put a circle around the 9x and the minus 4x. Remember to include the sign. I'm going to put a box around the minus 3 and a box around the plus 10, and that will allow us to simplify correctly. 9x take away 4x is 5x, minus 3 plus 10 is 7. Subtract 7 from both sides, we have 5, 5x, and x equals 1.